All right, you guys, so we're now into section 4.3. We've been concentrating a lot on lines. F of x equals mx plus b, and we're able to do quite a bit. We're able to graph very easily from this line form, do some applications from this line form, and that's pretty much what we're going to try very hard to do with quadratic functions. So let's go ahead and get started. Let's go ahead and take a look at some groundwork first. I think we've done these enough times, right? When you're graphing something with an x squared in it, right, the graph is going to be a parabolic shaped graph. So it's going to be something that's basically a U shape opening up, or it might be a U shape opening down, right? So that's basically what every single parabolic / quadratic function has, right? Because of course we know that f of x, right, a classic quadratic is ax squared plus bx plus c. So there's our x squared. So we're expecting some sort of U shape down or some U shape going up, right? And so for our purposes, how about we just take a look, let's xy graph, right? And let's just say we have a parabola that's opening up over here, right? And then we have another parabola that's opening down over here. Okay, so just to kind of give us some perspective on an xy axis, because it turns out that every parabola, whether they're opening up or down, has some aspects to it. And one of the first aspects that comes down is that there seems to be a low point or there seems to be a high point. All right, so that is called the vertex. So every single parabola has a vertex that's associated with it. If we're opening up, it's basically an absolute minimum. All right. If it's opening down, it's an absolute maximum, right? To use some language that we've learned previously in this class. So every parabola has a vertex. Another thing that happens is that there is some symmetry going on. Okay, not symmetry in the traditional sense about being symmetric about the x, the y, or the origin, but if we were to put a vertical line right through that vertex, the idea is that the picture on this side mirrors the picture on that side, all right? Or from here it mirrors this. So it's symmetric about some axis of symmetry, which we'll put in some more detail in a moment. So it does have an axis of symmetry. It's not necessarily the y or the x-axis, but there is some line where the graph looks like one or the other. I think a third one is that they're either up or they are down. All right, and then a fourth one, they are stretched or compressed. Okay, so what I mean by stretch or compress, that takes us back to what we just learned in 3.5, where we can take a graph, right? So everything is based off of the x squared function, but we can make it look a little skinny, like maybe this guy here, or we can flatten it out like this guy here. As a matter of fact, we know this one, not only did we flatten it out, but we also multiplied by a negative to get it to also flip, as we learned in 3.5. But those are the four major things. There's everything has a vertex, absolute min or an absolute max. Every one of them has an axis of symmetry. They're either opening up or down, so a U shape up or a U shape down, or they might be stretched or compressed in some sort of way, right? And it turns out that we can take all this, and if we think harder, right, there are four major ways that we can transform basically a graph. And technically there's only three because one goes with the other. But the idea here is, let's just go ahead and kind of label some things. Let me label this one here, right? Let's just call that data point right there H, comma, K. All right, and when I do that, right, it looks like this graph, right, we can shift it over to get, we can talk about a shift left or right. We can talk about a shift, oops, I can't spell today, up or down. All right, and if we go with H and K like I've done here, right, to get a shift left or right, we're basically taking our X, and how about I just say we're subtracting, we could be adding that H as well, right? So that's how we would get shift left or right. To get a shift up or down, I would have my f of x equaling, or excuse me, add or subtract some value, and I'll call it k. So h is how much, since I'm shifting to the left or to the right, and then k is whether I'm going up or down, giving us the vertex at hk. And then of course we can have a vertical stretch or compression, right? And so that's some constant, call it a, times our function. So if we put these three things together, and I'll talk about the fourth one that's happening in a moment, but if we talk about these three things together for x squared, here's what our new function looks like, right? It looks like sum a, x minus h squared, and plus k. Right? And then the fourth thing I'm talking about is that this axis of symmetry always occurs along the line x equals h, right? X equals h. So when we find the axis of symmetry, when we find the vertex, by default we've also found the vertical line that represents the axis of symmetry. So that's what I meant by the four. There's actually three major transformations happening to the graph of x squared. We're shifting it left or right, we're shifting it up or down, or we're stretching it or compressing it with some a. So what we basically put, when we put this all together, I kind of did this next part, what we have just built is what's classically known as the standard form of a quadratic function. And it is a very, very useful form, right? That would be f of x equals sum a, x minus h squared, and then plus k. And what this form is basically telling us, right, is that h and k is our vertex. So the movement left or right, the movement up or down is basically telling us where our vertex is going to be. What that also tells us is that x equals h is our axis of symmetry. Okay? And then the a, what that basically tells us, right, a is telling us whether we're going up or down. In this case, a is going to be positive, and here a is going to be negative. And so we get that reflection axis going on, which maybe goes back to the idea that there's four major transformations. If it's a is negative, we're actually reflecting through the x-axis. And that is very valuable information, because the idea then is if I give you something like f of x equals x squared plus 3x minus 4, something goofy like that, right? Notice that this form isn't in this form right here, so it's kind of hard to tell where I'm at. But, and I'll build up to that story, but to graph, if I know where the vertex is, and I know where the axis of symmetry is, I can basically start by plotting by moving over h units, moving up k units, or whatever the case might be. I've got my axis of symmetry, and because of the symmetry, all I really need to do is if I can find one point over to the left of it, its mirror image is over to the right, and before you know it, I have a really quick sketch of my parabola. Now, of course, this is not as fast as y equals mx plus b, but it kind of works the same way. H and k gives us a point to plot. It gives us an axis of symmetry, and all we have to do is do some work finding a second point, and then we use our axis of symmetry to basically find that third point. And as you guys know, I'm a pretty big stickler in finding at least 3 solution points to the graph. There's 3 good ones. You connect them, you basically have graphed your quadratic. And you have everything that's going to happen. You got a vertex, a high or a low point. You've got an axis of symmetry where they're mirror image of each other. We know if we're opening up or down. Again, that's that a value. Positive, it's opening up. Negative, it's opening down. And then a stretch or compression. That tells us if a is greater than 1, right, we're stretching. If a is a fraction between 0 and 1, we're compressing. So everything I need to know about that function with regard to its translations is right there for the taking, and it makes it very easy to graph. So there's our standard form. Our next move is let's go do some graphing using this form, and I'll show you, how relatively easy it is. Again, it's not as easy as y equals mx plus b. Nothing's ever going to be that easy, but as far as quadratics, it's pretty simple. So that story's coming in a video coming soon. I'll see you then.